Ideal op-amp characteristics. The figure shows an ideal op-amp. This is the figure. It has two input signals, V1 and V2, applied to non-inverting, that means plus, and inverting minus terminals respectively. The following things can be observed for the ideal op-amp shown in figure. First one, an ideal op-amp draws no current at both the input terminals. In ideal case, these currents are nothing but the base currents of the transistors, which are used to construct the differential amplifier. Differential amplifier is the first stage of the operational amplifier. That means I1 is equal to, ideal case, I1 is equal to, I2 is equal to 0. I1 is equal to I2 is equal to 0 means that its input impedance is infinity. Open circuited condition. That means here Ri is infinity. Any source can drive the operational amplifier, and there is no loading on the driver stage because due to that input impedance, open circuit terminals is directly connected to any driver stage. Therefore, loading effect is neglected. Loading effect on the driver stage is neglected due to infinite input impedance of the op-amp. The gain of an ideal op-amp is infinity. That means open loop gain of an ideal op-amp is infinity. Hence, the differential input Vd is equal to V1 minus V2 is 0 for finite output voltage. V0 is finite. We know that open loop gain is equal to open loop gain of an operational amplifier is equal to output voltage by input voltage Vd. Vd is equal to V0 by AOL. AOL is infinity, V0 by infinity, that is equal to 0. Vd is equal to V1 minus V2. V1 minus V2 is equal to 0. Therefore, V1 is equal to V2. The gain of an ideal op-amp is infinite. Hence, the differential input Vd is equal to V1 minus V2 is essentially 0 for the finite output voltage. The output voltage V0, one is V0, is independent of the current drawn from the output terminals. V0 is independent of the current drawn from the output terminals. Thus, its output impedance is 0. R0 is 0. And hence, output can drive any infinite number of other circuits. These properties are expressed generally as characteristics of an ideal op-amp. The various characteristics of an ideal op-amp are infinite voltage gain. AOL is infinity. It is the differential open loop gain and is infinite for an ideal op-amp. Two types of gains are there for the differential operational amplifier configuration. The first stage of that op-amp is the differential amplifier. Two types of gains are there, differential gain and the common mode gain. Common mode gain is particularly meant for noisy signals. Differential gain is the actual gain or open loop gain of that operational amplifier. AC is 0, AD is infinity in ideal case. Infinite input impedance. Input impedance is denoted as RIN and is infinite for an ideal op-amp. That means this ensures that no current can flow into an ideal op-amp. No current can flow into an ideal op-amp. That is I1 is equal to I2 is equal to 0. These two currents is equal to 0. That means open circuit condition at the input side, that is RIN is equal to infinity. Zero output impedance. R0 is 0. The output impedance is denoted as R0 and is 0 for an ideal op-amp. This ensures that output voltage of op-amp remains same irrespective of the value of the load resistance considered. As the load resistance changes, output voltage remains constant. Zero offset voltage. In presence of small output voltage, though even V1 is equal to V2 is equal to 0 is called an offset voltage. V1 is equal to V2 is equal to 0 means both the terminals are connected to ground. Therefore, some voltage, output voltage is observed. That is called as offset voltage. In case of ideal operational amplifier case, it is zero for an ideal op amp. This ensures zero output for zero input signal voltage. Both V1 and V2 equal to zero. VD is also zero. Therefore, output voltage equal to zero in ideal case. Infinite bandwidth. Bandwidth means the gain, open loop gain of an op amp is constant as the frequency is observed from 0 to f is equal to 0 to f is equal to infinity. F is equal to 0 means DC signal. F is equal to infinity means AC signal. From DC signal to AC signal, the gain, open loop gain of the op amp is constant. Bandwidth is equal to, this one is F1, this one is F2, F2 minus F1, infinity minus 0. In ideal case, that is infinity. It is used to amplify DC signals as well as AC signals. Ideal case, infinite bandwidth. Infinite common mode rejection ratio. Generally, CMRR is defined as a ratio of differential gain, voltage gain to common mode voltage gain. Generally, common mode gain is low value, zero value. Differential gain is high value. The op amp is used to amplify the difference between the two input signal. That is the reason differential voltage gain is high. AD is infinity and AC is zero. That is equal to common mode rejection ratio is infinity. Common mode rejection ratio is defined as the ability of the op amp to reject the common mode signals. Next one is slew rate. Slew rate is the change in output voltage occurs simultaneously with the change in input voltage. Whatever the changes we have to observe at the input side, same changes observed at the output side as frequency increases at the input side. As frequency increases at the input side, the input voltage is changed from 0 to 5 volts. The same change will observe at the output side from 0 to 5 volts instantaneously. The input waveform is a square wave. The output waveform is also a square wave. Slew rate is an important parameter of an op amp. When input voltage is applied, step type means that is the combination of two steps are nothing but the square voltage, which changes instantaneously. The square wave voltage changes instantaneously. Then the output also must change rapidly as input changes. This is the input side changes. The output side changes is also same as the input side changes. This is the output waveform here. If output does not change with the same rate as that means some delay is there here. Some delay is there. Here, some delay is there. Some delay. Some Precedial waveform is observed at the output side. So that is called as some D delta T. Delta T. Slew rate is defined as the change of output voltage with respect to time. Delta T. Maximum rate of change of output voltage with respect to time. Delta T is equal to 0. Slew rate is infinity. Slew rate is infinity means the shapes of the output side is same as the shape of the input side wave. Infinite slew rate indicates that output changes simultaneously with the changes in the input voltage. No effect of temperature. As the temperature changes, some parameters are there. IB is the bias current, IIO is the offset current, and input offset voltage, VIO, output offset voltage, V00. These parameters are constant even temperature changes. Power supply rejection ratio. Power supply rejection ratio means suppose we have some input offset voltage, VIO. The input offset voltage changes with respect to either power supplies plus VCC or minus VEE. Suppose VIO changes with respect to plus VCC, VEE is constant. VIO changes with respect to VEE, VCC is constant. This one is VCC is constant. Both are in voltage terms. That is, unit is microvolts per volts or millivolts per volts or microvolts per volts. Ideally, its value is 0. Even power supply, external power supply is used to power the power amplifiers. Due to DC source will require to power the power amplifier with the help of pins. Pins of the power amplifier are +7 and +4. +7 is particularly meant for plus VCC, -4 is particularly meant for minus VGE. Ideal case, it is 0. These are the some important characteristics of the ideal op-amp. Open loop voltage gain, AYL infinity, input impedance, RIN is infinity, output impedance, R0 is 0, offset voltage or output offset voltage is 0, bandwidth is infinity, CMRR, common mode rejection ratio is infinity, slew rate is also infinity, power supply rejection ratio is 0. These are the some important ideal characteristics of the ideal op-amp. These characteristics will help to solve the operational amplifier problems easy.